Hello friends, welcome back. Today I'll talk about some of the important points that we should understand before we start working with a simplex algorithm. So let's talk about the standard formulations, canonical formulations, Slag variable, and surplus variable. So let's get started with the standard formulations. So standard formulations to a linear programming problem should have these four different points. The objective functions of the given problem should be either maximization or minimization. All the constraints should be of equality type. Objective functions is either maximization or minimization. The right hand side of the constraints should all be non-negative. All the distance variable involved should be greater than or equal to 0. All the distance variable involved should be greater than or equal to 0. If that is so, that particular formulation, we call it a standard formulation. So this is a standard formulations to a linear programming problem which is presented in the form of matrix notation. Now let's go down to the canonical formulation and try to understand this. So what is a canonical formulations? These 7 points will define the canonical formulations. The first 4 points over here are the points that we have in the standard formulations. The objective functions should be either maximization or minimization. The constraints should be all equality type. The distance variables involved should be all greater than or equal to 0. The right hand side values of the constraints should be non-negative. These are the 4 points that we have seen in the standard formulation. So along with this, we should have another 3 additional conditions so as to have the canonical formulations. Now, when we write the canonical formulations, we'll divide the whole variable into 2 types. One is a basic variable, the other one is non-basic variables. So the objective functions should be purely in terms of the non-basic variable that you have selected, and the total number of basic variables in the problem should be equal to the total number of constants that we have. Is constraints should have exactly one basic variable with 1 as the coefficient. Is constraints should have exactly one basic variable with 1 as the coefficient, so that when we combine the coefficients of this particular basic variable from all the constraints, we should be able to have an identity matrix. Now A1 is the coefficient matrix of the non-basic variable in this particular matrix notation of the canonical formulations. So these 7 points will give us the canonical formulations to a linear programming problem. And the formulation that I have in the form of matrix notations is a canonical formulation. With an objective function either in the form of maximization or minimizations, the variables non-negative, the right hand side values of the constants are all positive, the constants are equality, all the variables involved are greater than or equal to 0. Its constraints should have exactly one basic variable with 1 as the coefficients. So this is what is a canonical formulations. Now let's go to the slag variable. A slag variable is the variable that we introduce in a constraint of less than equality type to convert this into equality. So a non-negative variable s1, which we introduce in this type of constraint so as to convert this less than into equality, we call it slag variable. So any variable which is added to the left hand side of the constraint, any non-negative variable which is added to the left hand side of the constraint to convert a less than equality into equality, we call it slag variable. Similarly, a surplus variable is a non-negative variable which is subtracted from the left hand side of the constraint to convert a greater than equality into equality. So these are the slag, and these are the definitions of the slag and surplus variables. We'll try to understand these 4 different these 2 formulations along with these 2 definitions with more examples in my next video. Thank you for watching.